Welcome to another session of Ebenezer GATE coaching classes. This is a problem that appeared in GATE 2013. It is a multiple choice question for 1 mark. In the circuit shown below, the knee current of the ideal Zener diode is 10 milliamp. To maintain 5 volt across RL, the minimum value of RL in ohm and the minimum power rating of the Zener diode in milliwatt respectively are. We have got 4 options. We'll have to find out which is the right option. Now for the Zener diode to be in breakdown, we should assume that VZ is 5 volt and the input voltage is 10 volt. So the voltage across the 100 ohm resistance is going to be, let me call it V100, is going to be 10 minus 5, which is 5 volt. So the current through the 100 ohm resistance is going to be fixed when the Zener is in breakdown, and it is going to be 5 divided by 100 or 0.05 amps. Now 0.05 amps can be written as 0.05 into 1000 milliamps, or this is 50 milliamps. Now I will have to find out what is the minimum value of RL. Now current through 100 ohm is going to be fixed at 50 milliamp. So this current is going to be fixed at 50 milliamp. Now the minimum current that should flow through the Zener diode for it to be in the breakdown region is 5 milliamp. So is 10 milliamp. So this current minimum is 10. Minimum is 10 milliamp. So when this is minimum, maximum current flows through RL. So the current through RL, let me write it as IL, is going to be I100, that is the current through the 100 ohm resistance, minus current through the Zener diode. Now the minimum current, maximum current through the load is going to be I100 minus minimum current of the Zener diode. So this is going to be 50 minus 10, which is 40 milliamp. Now the minimum value of RL is going to be, RL minimum is going to be VZ is the voltage across RL divided by IL maximum. So this is going to be VZ is 5 and IL maximum is 40 milliamp. 40 milliamp can be written as 40 into 10 power minus 3. So this is equal to 5000 by 40, which is 500 by 4 or 125 ohm. So 125 ohm is the minimum value of RL. And we'll have to find the minimum power rating of the Zener diode. What is the minimum power rating that should be in the Zener diode? Or we'll have to find out what is the maximum current that is going to flow through the Zener diode. We know that the current is limited by this 100 ohm resistance, and the current through the 100 ohm is fixed at 50 milliamp. So the maximum current that can go through the Zener diode is limited to 50 milliamp. So IZ minimum, maximum is going to be, IZ maximum is going to be 50 milliamps. So VZ is fixed at 5 volt. So the power dissipated and in the Zener diode is going to be, let me call it PZ, is going to be 5 times 50 milliwatt or 250 milliwatt. So this is the minimum rating that should be there in the Zener diode here. So the answer is RL is 125 and the minimum power rating of the Zener diode is 250. So the choice is P. Thank you. God bless you.